Okay, this next part is section 1.6, part B, finding the equations of linear models by regression. Okay. When I see regression, regression is a technique that we're going to use our calculator for. And when you're going to do regression, you're going to be finding the model on your calculator, on your graphing calculator. This is something that you have to have a graphing calculator like the TI-84 to do. Okay. So, example 4, we're looking at the FBI burglary set again. This is the same data set that was in the last example in part A of 1.6. But here we have more data. I believe that in the last example, they only told us the 1992 and the, I think it was the 2011. I don't remember. I'll have to look real fast. Yep, 2011. Okay. I guess I could have looked later, but it gave us those two. Now we have a lot more data here, so we are going to use regression, and we're going to be able to find a model that goes through all the data. Okay, so part A is asking us just to look down here at this table and label a couple things, label the axes and get some scale. So I know I'm going to label the independent axis as T, the dependent axis as B, or B of T, since it was B is a function of T, and units 0, 1, 2, yeah, these look like I can just label them by 5 because I can see that they're counting up by 1, right? Because if 0 is 1990, then 2 is 1992, and so on. We have our 0 down here, and then if I'm going to go up to 11,000, maybe these go by hundreds, like 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000, 1100, yeah, that could be close to 1200 here. So these must go by 100. So I'm just going to label the ones that stick out with the even. So 200, 400, 600, 800, 1000, and 1200. Okay, it just was asking me in part A to figure out the scaling on this model. Okay, and make sure that it was an even scaling, of course, otherwise it wouldn't be appropriate. Okay. Now, part B asks me to draw the linear model that we used in the previous example. Notice it used the first and last point. So there we go. So if I'm going to draw the model that goes through just the first and last points, it would look, oops, my ruler slid a little bit, darn it. It would look like this. There we go. Okay. Now, what you can see, it's the top line right there, the second one I drew. What you can see though is it's not very good. Those 2 points are the highest 2 points. Every other point is below that line. Okay, so it's not going to do a good job. It's too high, right? It's too high. It uses points that are above all the other points. We need to lower it down to fit more points. Okay, should, I'll put it in quotes, but should center on the data. Okay, to try to fit the middle. Okay, so this line is not so good. We're going to try to make a better linear model. And I could try drawing a better model. Oh, I guess I could have written this part right here. The should center on the data is how I would make a better model. But there are so many different ways to pick 2 points. What we want to do is use linear regression, because linear regression is going to take all of the points into consideration, not just any 2. Okay? Now, if I flip my page to the back, there are some calculator instructions for how to use your calculator to do linear regression. I'm going to walk you through it in a minute, but first let me just point out a couple things about the regression. I'm going to use the stat menu to enter my data. I can just follow along and enter my data here. So the stat menu, as you can see, it's right here, stat, and it brings up a menu that looks like this, and I want to hit 1 or enter to get into the edit menu. And then I am going to fill in the values in list 1 and list 2. So I'm going to go back over here to the year, and it looks like actually I can flip to the next page because it just repeated for me here to find the linear regression model. Before we can enter it though, remember I'm not going to enter 1992. I'm going to enter 2 since we're going years since 1990. 1992 is 2 years since 1990. So I'm just going to fill in what years I'm going to write down over here. So I know my T values and my B values. So 2, 4, 6, 8. So 2000 was 10 years, then 12, then 14, 16, 18, 2010 is 20, and 2011 is 21. Okay. So back over here in the calculator, we'll type in those values in the first row. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 21. And then we're going to go in and just fill in the other column in list 2. So you should always make sure at the end that your lists match up, that one is not longer than the other. If that is the case, it's a good indication that you missed one of your points, so just want to go back and double check. Okay. Now, I'm going to do a couple of things. The first thing I want to do is just do a scattergram, and I'm not sure if that's in the directions real quick, so I'm going to flip over and look. Yeah, so scattergram. We're going to do the scattergram first, so I'm going to show you, walk through this real quick, and then we're going to talk about the scatterplot, and then we'll go back and we'll do the regression, which is the next calculator direction page. Okay? So I'm going to do a scattergram. So to do the scattergram, what I want to do is go into my y equals menu here, and I'm going to clear out any equation that I previously graphed, and I'm going to go up and turn my plot 1 on by hitting the enter key to toggle it. So you can see if you move back down that it's dark. Okay, I also want to go into Scatterplot, which is in blue right above my y equals button. So I'm going to hit second y equals to get into the Scatterplot menu. And you can see plot 1 is turned on. And I just want to hit it to make sure that it is type dot, scatter dot, and that list 1 and list 2 are here. If they're not, you can access list 1, list 2 by hitting second, and then the list 1 is above 1, list 2 is above the 2 key. So we could change that to list 1, list 2. All right, so that's the mode you want to be in. And then, so you're in y equals, no graphs in there, your plot is turned on. What we're going to do is zoom, and you want to go to option 9. You may have to scroll down, but zoom stat, because you put your data in the stat menu. So option 9, I'm going to hit the 9 key, or go down to that option, and hit enter. It's going to zoom in on my data. Uh-oh. I noticed right away I must have typed my first point incorrectly because it doesn't line up like the other ones do. So I'm going to go back and fix that. Stat edit. Yep, I see that right there. My first one was supposed to be 1,168. I typed that too fast. Only came out as 168. So let's just type that again. 1,168. Okay, so back to zoom stat option 9. It's always a good idea just to look at your data real quick to make sure that everything looks correct, especially when you can compare it to a graph that you already have of the data. Now, this graph looks quite a bit different from this one. To get them to look the same, that's why my scale comes important. I want to match the scale here. Okay, so I'm going to go to my window and I'm going to change it to match this scale. Okay, so the x min is 0. The x max is, if that's 1520, that one must be 25. So I'm going to go to 25. The scale can be 1, that's fine. The min on y is 0. The max on y, if that's 1200, must be, 1400. Okay. Now I'm going to hit graph, and I'm going to see something that looks a lot closer to what we had graphed right there. There we go. So now I can verify that my graph looks correct. I haven't missed any of my points, and I fixed the one mistake I already had. Cool. Now, that's all before I get the model. I get my scattergram, I take a look at it. Now I want to see if a linear regression is appropriate. I want to see if this looks like I could fit a line. It does, so I'm going to do regression. Back into the stat menu. Edit is where I enter the data. I want to go over with the over arrow into the calculate menu to do a regression. And there are lots of different types of regression in here. And we're going to use a couple different types during the class. But the first one I want to use is option 4, lin reg, short for linear regression. Hit enter. All right, and it comes up and asks me what lists I want to choose. List 1 and list 2 is the default, and that is where I put my data. So I'm going to keep those there. I'm just going to go down to calculate. Now, If yours is showing up A and B and not showing your R-squared values right now, don't worry about those. We'll talk about R-squared later. But A and B are the two numbers I need for the coefficient of X and B. A is actually the slope, so you can call it M if you like. Okay. So when I write my linear regression model down, it is going to be B of t equals, I want 4 places in most cases, if I'm not told, I'm going to use 4. So I'm going to use negative 21.5091. Oops, I accidentally cleared it. I got to do my regression again real fast because I can't read it. So it was negative 21.5091 t plus b, which is 1082.7898. So that should be the model that matches your A and B values on your calculator. Okay, so a couple of questions about this model. What would the linear regression predict as the crime rate in 2015? So 2015, that is still a t-value of 25. So once again, we're going to find b of 25 using this model. So we've got to take negative 21.5091 times 25 plus 1082.7898. I know it's 25, by the way, because if you take your 2015 and you subtract your starting year, which was 1990, that gives you 25, right? Okay, so clear my calculator and then take our negative 21.5091 times 25 plus 1082.7898. You come up with 545.0623. Okay. So 545.0623. All right, so in 2015, the burglary rate was 545.0623. Last, we got the question up here, was this interpolation or extrapolation? Remember that interpolation is a prediction that you make in between first and last of your data points. Extrapolation is outside. Since 2015 is beyond the last data set, this one was extrapolation. And that's relevant because extrapolation means that it's a less likely prediction than it would be if it was interpolation. All right. Part C, we want to predict when we had 800 burglaries. Okay, so once again, that's the B value. So we're going to set 800 equal to this model, the negative 21.5091 t plus 1082.7898. Solve for t, so that means I need to subtract 1082.7898 from both sides. Alright, so let's take our 800 minus 1082.7898. Gives us negative 282.7898. Equals negative 21.5091 t, and divide both sides by negative 21.5091. Okay, so divide by negative 21.5091 gives us 147. All right, so 13.1474 equals t. All right. That's a year value. So to find the actual year, we need to add it to our starting year. So we're going to take that 13.1474 and add it to our 1990. So if you add 1990, that gives you 2003. 0.1, still 2003. So we're going to say in 2003, the burglary rate was 800. Okay. Now back to part D. Which model does a better job in making predictions, the one created by hand with 2 points or the linear regression model? Okay. Let's do some comparison. The previous model, when we did it by hand, we predicted, there it is over here, that it was going to take until that in 2015 the burglary rate would be 603. Here we predicted that in 2015 it would be 545. So this one we know was too high because that model was using higher points. So the lower value is going to probably be more realistic here. And finally, let's see, 2007, the burglary rate was 800. 2007, we don't have data for it, but it seems like it shouldn't have been 800. It should have been not 800, closer to 2003. Yeah, it's closer, a little bit closer. That's still a little high, but our model isn't going to be perfect. This is definitely more realistic, though, because 2007, it already should have been going down further than it was up here. Okay. So the regression model made the better prediction, and we'll have a couple of reasons here. Regression always makes better predictions than any by hand model, but especially the by hand model that just used the highest 2 points. Regression model because it considers all the data. And one more visualization. If I was to go back to my graph and graph the equation, the negative 21.5091x plus 1082.7898, if I graph that equation, hopefully you're going to see that it fits the center of all of my data. Some are above, some are below, but it fits the center, which is what a good model is supposed to do. Okay. So it considers all of the data and that it fits the center. So these are just two good reasons anytime that you're looking at a regression model, why the regression model is going to be the best. All right. Okay, that was a lot on that one question. Let's see if we can get to another one. Example 6. The average gasoline tax in $2010 per 1,000 miles driven is shown below. Consider the scattergram. Explain why linear regression would be the best way to find the model. If there are more than 2 points and the data looks linear, you're going to want to use regression. Okay. So we want to consider all the data. There are more than 2 points. There are more than 2 points. So we need regression so that we can consider all the data. To factor in all the data. Okay. Part B, find the regression model. Okay, so I want to use years since 1990 again. So let me write in my t values up here. I'm going to be since 1990. This is going to be a 5, 8, 11, 14, 17, and 20. If I just take each of those years and subtract 1990. All right, so I need to go into my calculator. I need to go back into stat, into edit. First thing I want to do is clear out the old data. So go up to the top, hit clear, then hit enter, and it'll clear the whole list at the same time. So up, clear, enter. That list is clear, and I can re-enter the data for this problem. So 5, 8, 11, 14, 17, and 20. 28, 27, 24, 23, 20, and 19. Okay. I'm going to graph it, a zoom stat, just kind of see how it looks. Oh man, did I do one of them wrong again? That one looks too low. Not having any luck today. So edit. Let's see, 5. Maybe one of them's wrong. Let's see. 528, 827, 1124. Ah, that's the one. It was 1124, not 124. I knew there was one of them wrong. Okay. So zoom stat. Hopefully that looks a lot better. That looks closer to the data, and I could change my window to get it exactly the same. All right. Good thing I'm graphing these because I'm catching mistakes I made by typing too quickly. All right. Now let's get the model. So stat, over to calculate, option 4 for linear regression, and just go down to calculate. So this model is going to be called A of T, A for average, and the slope value looks like negative 0.638. It says 3 places, T plus 31.476. Okay, hopefully your numbers, I know that's a little fuzzy, hopefully your numbers also match that. All right, part C, find the A-intercept, talk about what it means, find the T-intercept, talk about what it means. Okay. If I want an A-intercept, that's going to be the place where T is equal to 0. Okay, so I'm really looking at plugging in 0 for T. If you plug 0 in for T, you get 0 plus 31.467 is 31.467. So what this means is at T equals 0, which has to be in the starting year, right? So that has to be in 1990. 1990 plus 0 is 1990. So this means in 1990, the average gasoline tax was, per 1,000 miles driven, was $31.476. The average gas tax was $31.476 per 1,000 miles. Okay. And part D, find the T-intercept. What does it mean? So the T-intercept, if I want to find T, that's when A is equal to 0. So I'm going to plug 0 in for A, equal to negative 0.638 T plus 31.476. I'm going to solve for T. Since this side is empty, I'm going to go ahead and add the 0.638 T to both sides. That way I've got 0.638 T equals 31.476. Then I want to divide both sides by 0.638 to solve for T. Okay. So clear. Take my 31.476 and divide by 0.638. Got 49.335. T equals 49.335. Now, that's in reference to my starting year, and my starting year was 1990. So I'm going to add that on. Add on 1990, and I get 2,039.335. But the year would be 2039. Okay? So my answer is going to be in 2039. The average gas tax will be, and remember we're finding an intercept when A is equal to 0, so the average gas tax is going to be $0. And again, that's probably not realistic, however, that is the prediction based on this model. Okay, we'll continue the rest of the section in the next video.